In the last lesson, we talked about different properties of parallelograms. So if a quadrilateral is a parallelogram, there are some different things that we knew. What are some of the things we know about a quadrilateral that is a parallelogram? Okay, it has two pairs of opposite sides that are parallel. Kendall, tell me something else. The diagonals bisect each other. So if you draw in the diagonals, they bisect each other. Austin, give me another thing you know. Okay, that's the same thing as saying the diagonals bisect each other. There's two things that have to do with sides, right? What's the other one about sides? Okay, the opposite sides are congruent. Just so this doesn't get crazy, I'm gonna just change colors but still use 1 and 2 marks. Okay, Grace? It's not, a parallelogram in general doesn't have to be regular. If it's a square, it will be regular, but in general does not have to be. There were 2 about sides, 1 about diagonals, and 2 about angles. Dribble? They're not complementary either. Yeah, they're supplementary. So all the way around, the angles are supplementary. And then 1 more about angles. Lily? Right, opposite congruent angles. So these angles are congruent, and these angles are congruent. This is not the best markings just because I'm putting everything on one thing. But remember, there's 2 about sides, 2 about angles, 1 about the diagonals. Okay, so the definition, which one of those is the definition? Well, it's called a parallelogram, right? The definition is the one that says if a quad has 2 pairs of opposite sides that are parallel, then it is a parallelogram. Okay, so that what we're talking about here are going to be different ways of showing that the quadrilateral is a parallelogram. Okay, so in section 2, we had, okay, we know this is a parallelogram. Now we're going to say different things that are true about it. Okay, in lesson 6.2, you were given that it was a parallelogram and you're listing the properties. Okay, we're going the other way around now. Remember, converses are when you kind of like read it backwards. So we're saying if this was true, then it would be a parallelogram. So the first way to prove that it's a parallelogram is, and all of these, they have to be quadrilaterals, right? We know that in order to be a parallelogram, it has to have 4 sides. So if a quad has 2 pairs of opposite sides that are parallel, then it is a parallelogram by definition. The definition of parallelogram is a quad with 2 pairs of opposite parallel sides. That's your first way, okay? That's the definition. The rest of them are all theorems. So the next one says, if, what is that showing? What is this showing right here? Okay, and it's 2 pairs of opposite sides that are congruent. And notice that Geron said opposite sides. He didn't just say it has 2 pairs of sides that are congruent. He said they're opposite sides that are congruent. Okay, so if a quad has 2 pairs of opposite sides that are congruent, then the quad is a parallelogram. All of these are going to end with, then the quad is a parallelogram. Okay, so 2 pairs of opposite parallel sides. I guess I should have highlighted that up there. Let me do that here. 2 pairs of opposite congruent sides. 2 pairs of opposite parallel sides. Okay. Then it will be a parallelogram. So that's way 1 and way 2, method 1 and method 2. Okay, method 3. So method 3 says that we've got that situation. It says A and B add to 180 and A and D add to 180. Okay, what does it mean if they're adding to 180? They're supplementary. So Notice that they're showing that by saying x and 180 minus x. I want to buy them a new cart. Sure, we're not in the middle of anything. Okay, so these two angles have to be supplementary. And also these two angles have to be supplementary. So that's going to force those opposite angles to be congruent, right? But if I told you, let's just put some numbers here. Let's say I told you this is 50 degrees. What would that make angle A have to be? 130, because 180 minus 50 is 130, right? And then if that's this angle is 130 and this one's supplementary, it forces that angle to be 50. Now I didn't say anything about that last angle, but we know this last angle would have to be what? It would have to be 130 because they have to add to 360, right? So it's going to force all those angles to, to be the opposite angles to be congruent and whatever. Okay, so this way is if a quad has an angle that is supplementary to both consecutive angles, supplementary to both consecutive angles, then the quad is a parallelogram. So it cannot just be supplementary to one, it has to be supplementary to both. Okay, so can you think of a shape, like what if I had a quadrilateral and we knew that these two angles were supplementary, but that's all you knew? If those are supplementary, what does that make? Here, I'll call this A, B, C, D. What sides are parallel if B and C are supplementary? What sides would be parallel? I need two sides. So like segments, what and what? Michael? Did you say AB or did you say AD? These two? Where's the transversal? Okay, if I use those two lines in this transversal, are B and C consecutive interior angles? Okay, so which lines should be parallel then? So if these are your lines and that's your transversal, then B and C being supplementary forces these lines to be parallel. Now, why is that not enough to show it's a parallelogram? Do you know a quadrilateral that has only one pair of parallel sides? Yes, you do. I promise you do. What is a quadrilateral that has one pair of parallel sides and one pair that's not parallel? Yes, a trapezoid. Thanks, Diamond. So you have to make sure that it's both consecutive angles, okay, because this is kind of like a counterexample type of situation here that I'm drawing for you. A trapezoid has a pair of parallel sides and another pair that's not parallel. Okay, so you will have supplementary, like whatever this angle measure here is, whatever the angle measure here is, it will have to be supplementary to the one below it. However, it will not be supplementary to the other one. So this could be like 100 and that could be like 80. But if it's a trapezoid and these sides aren't parallel, then that 100 will not make the other consecutive interior 80. So on a trapezoid, you'll only have that side and that side parallel and that transversal, but it will not make the other. Same thing over the other side will also have supplementary, but it's only going to make the top and the bottom parallel. Okay, so you have to make sure it's consecutive, supplementary to both consecutive. Let me go up here and also draw you kind of like why it's important to say opposite sides that are congruent. Here is a shape I'll make this look good. Okay, here's the shape. Do you know what this shape is? That's a kite. Once I put the markings on it. This is a kite. Okay, does a kite is an actual geometric shape. Does a kite have two pairs of congruent sides? Yes, but they're not the opposite sides. So it's super important that you get the fact that the opposite sides have to be the ones that are congruent, because otherwise it might be a kite. So in a kite, you have two pairs of consecutive sides that are congruent. Okay, so when we're thinking about this, we have to be given two pairs of opposite sides that are congruent. Any two pairs the sides being congruent is not going to be sufficient. You have to have opposite sides. Okay, what is number 4? What is that one showing? Okay, how many pairs? 2. If this is way number 4, if a quadrilateral has two pairs of opposite angles that are congruent, then the quad is a parallelogram. Okay, if it has two pairs of opposite angles that are congruent, then the quad is a parallelogram. For the way number 4, two pairs of opposite angles congruent, the reason it's important to say opposite is, sorry, let me try it again. Because this shape, if these are parallel, if these are parallel and those are congruent, what kind of shape is that? What kind of trapezoid? You guys know what you call that when it has two congruent sides like that? What do you call a triangle that has at least two congruent sides? Isosceles, yeah. This is an isosceles trapezoid. And an isosceles trapezoid, if this is, let's say this is like 70, what would the angle up here have to be? 100 and how much? 10. Okay, in an isosceles trapezoid, this angle is congruent to the other one on the, like to the left of it over there, and then these two are congruent. So this is a kind of quadrilateral that is not a parallelogram. Okay, it is not a parallelogram. However, it does have two pairs of congruent angles. So you have to be careful that you say two pairs of opposite angles that are congruent. Okay, so these little pictures that I'm drawing are to help you understand you have to have all those words there when you're using those theorems. Okay, this is kind of like a counterexample. It has two pairs of congruent angles, but they're not opposite. Okay, a kite has, let me go ahead and get rid of this. A kite has, sorry, I don't mean a kite. This one is a trapezoid. A trapezoid has angles that are supplementary to consecutive angles. So a trapezoid can have like 80 and 100 there, and it could have like 60 and 120 here. Okay, but these two are not supplementary. So just having one pair of supplementary consecutive angles is not going to be sufficient. You have to make sure you have two pairs. I mean, two pairs. One angle that's supplementary to both consecutive angles. Right. So this one, that 100 degrees, if this was going to be a parallelogram, it would have to be supplementary to the 80 degrees, but it would also have to be supplementary to this different color here, to the one over here, which it's not. Okay, so, and if it was, then that would force it to be a parallelogram. That's what we need for it to be a parallelogram. Okay, but you have to have one angle supplementary to both consecutive angles. Okay, so again, this one angle here has to be supplementary to the one on both, like each one on both sides of it. Okay, and then again, for a quad to be a parallelogram, we need opposite sides congruent, because if you just have two pairs of any sides that are congruent, it may not be a parallelogram. Okay, a kite is not a parallelogram. A trapezoid is not a parallelogram. An isosceles trapezoid, not a parallelogram. I'm going to keep talking to you about these other shapes that are not quads that are not parallelograms, because we're going to be talking about properties of these other shapes as well. So if you kind of get familiar with them now, it makes it a little easier later. Okay, number 5, way number 5. Let's see that orange here. Method number 5, a way to prove a quad is a parallelogram. If, what is that showing? These two are the same and these two are the same. How do you say that? They bisect. You kind of combine two things there, Diamond. Kara, what does she mean? Yeah, they bisect each other or they have the same midpoint. So again, all of these are converses of things we talked about, as far as the properties go. So if a quad has diagonals that bisect each other, or if you prefer, you can say share a midpoint. You don't have to say both if you're writing this theorem, but whichever one makes better sense to you, then the quad is a parallelogram. If the diagonals bisect each other, then the quad is a parallelogram. Now again, that doesn't mean the diagonals have to be congruent. It means they cut each other in half. The lengths themselves don't have to be the same. So each one of these, you know how there were 5 properties? I said that there were 2 that were about sides for the properties. There were 2 that were about sides, the parallel and the congruent. The properties about angles were that you had opposite angles congruent and you had consecutive angles supplementary. So, not wanting to go back, there we go. You had consecutive angles supplementary. All of these correspond, and then the diagonals bisect each other. All of these correspond to a property. Okay, if there are 2 pairs of opposite sides that are parallel, if there are 2 pairs of opposite sides that are congruent, okay, there's 2 about angles. If it has 2 pairs of opposite angles that are congruent, if it has an angle supplementary to both consecutive angles. And then this one is the diagonals bisect each other. Okay, if a quad has diagonals that bisect each other, then the quad is a parallelogram. And then there's one more that doesn't correspond to one of the properties, but it kind of mixes 2 different things. So for the last one, I'm thinking about a color I can use here. It's like red. The last one is different than the properties because it sort of mixes 2 different things together. Okay. If a quad has one pair of sides that are both, what is that showing? Congruent and parallel, then it's a parallelogram. Okay. One pair of opposite sides that are both parallel and congruent, then the quad is a parallelogram. So here we're mixing together the parallel and congruent, and that will make it a parallelogram. Now, you have to make sure that the sides that are parallel are also the ones that are congruent. So if you are using the BC and AD, they've got to both be parallel and congruent. You could use A, B, and C, D, but they also have to be, like the other option would be use the other sides, but they have to be parallel and congruent. Why would I'm going to draw just a, not to make it look anything special. Why would this be a problem? Okay, what kind of shape could that be? If you don't guarantee that the opposite sides are parallel and congruent, what kind of shape has a pair of parallel and a different pair of congruent? A trapezoid. What kind of trapezoid? An isosceles trapezoid. Okay, so you have to be careful. Again, the reason it says one pair is both parallel and congruent is because if you don't guarantee that, you might end up with an isosceles trapezoid. Okay, now trapezoids in general don't have to have any congruent sides, but an isosceles trapezoid does have congruent sides. Okay, so this is an isosceles trapezoid, and it has one pair of congruent and other pair parallel. And that again is not a parallelogram. So you got to make sure when you're checking for parallel and congruent that's the same pair of sides. Okay, those are 6 ways to prove parallelograms. And again, that's the first 5 all correspond to one of the properties. 2 pairs of opposite sides parallel, 2 pairs of opposite sides congruent. Those are ones about the sides. 1 angle supplementary to both consecutive, or both pairs of opposite angles congruent. Those are both about angles. Then there's the one about the diagonals bisecting each other. And then lastly, this one doesn't really correspond to as a converse of something from the last lesson, but it still means that mixing together parallel and congruent, that's going to make it a parallelogram. Okay, they're all summarized. Yeah. I'm going to make that a little bit skinnier. You see the parallel a little better. So if I just say, I'm thinking of a quadrilateral, it has a pair of parallel and it has a pair of congruent, then it doesn't necessarily have to be a parallelogram. Like maybe it is, and I just didn't give you all the information, but that's not sufficient because I could also draw an isosceles trapezoid and that would also satisfy that requirement. Okay, so here they're all summarized for you. It does not matter if you know that it's theorem 6-8. Like the numbers of those theorems don't matter at all. So don't worry about the 6-8, 6-9, 6-10. Okay, the first one is the definition because parallelogram, the definition is about sides being parallel. And then the other ones are theorems. But these are 6 ways to prove that a quadrilateral is a parallelogram. Hopefully it looks weird. Okay, given each of the following conditions, is A, B, C, D a parallelogram? If you want to copy, like, it might be a good idea, sorry. It might be a good idea to make copies here. So number 1, I'm going to put on the actual picture. And then, well, sorry, A, I'm going to put on the actual picture. And then B, C, and D, I'm going to put over here so that we can kind of show different drawings. All right, so I'll put A right here. Okay, so if it's yes, we should be able to write the theorem. And if it's no, we should be able to give a counterexample or explain why it's not. Okay, so if I tell you that angle A is congruent to angle C and angle B is congruent to angle D, does that satisfy one of those requirements for being able to prove that it's a parallelogram? Yes. Okay, so who can tell me the statement of the theorem? Okay, I need an if-then statement. Okay, okay, hold on. We don't know it's a parallelogram this time. So that's how this is going to be different than what we did in the last lesson. Because in the last lesson, I told you it's a parallelogram. And then in this one, we're concluding it's a parallelogram. Okay, So Blair, we don't know it's a parallelogram, and the hypothesis or conclusion is going to be then it's a parallelogram. What do we know? If a quad has, how many opposite angles have to be congruent? 2 pairs. Opposite angles congruent. Then what? Then it's a parallelogram. Okay, that's A. I'm going to scoot this over a little bit here. It's really in my other picture. All right, let's go over here and talk about B. B says A is supplementary. So angle A is supplementary to B and to D. So supplementary to B and supplementary to D. Does that satisfy one of the conditions? Yes. Okay. Ryan, can you give me that statement? Okay, so I didn't actually tell you that all of the consecutive angles that are supplementary, and I also want to make sure we don't think it just has to have one pair of consecutive angles that are supplementary. So the way we're going to ensure that is we're going to say one angle is supplementary to what? 2 angles where? If a quad has 2 consecutive, an angle supplementary to both consecutive angles, then what? Your conclusion on these is always going to be what? Then it's a parallelogram. We're proving that it's a parallelogram. We're concluding that it's a parallelogram, okay? All of these are going to end with, then it's a parallelogram. Yes, in a second. All of these are going to end with, then it's a parallelogram. If the quad has an angle supplementary to both consecutive angles, then it's a parallelogram. Which one is that up here? Yeah, that's number 3, right? What was the first one? What was that one? Which one is that? Number 4. Both pairs of opposite angles are congruent. Okay. C, we'll do over here. Okay, C says that A and B are supplementary. So C says these 2 are supplementary and these 2 are supplementary. Does that make it a parallelogram? What do you think? Yeah, it does. Which one does that correspond to up here? Okay, is that the third one? It says an angle supplementary to both of its consecutive angles. That's not what we have, right? Because we don't have one angle supplementary to both. We have a pair of supplementary, a pair of supplementary here, and we have a pair of supplementary here. So it's not the third one. Okay, so let's put some numbers on here and see what happens, Kara. Give me a number I could use for that angle. Okay, let's say that's 60. Let's say this is 60. What does this angle up here have to be? 120. So if those are supplementary, that's definitely 120. Now you told me that A and C have to be congruent. Is that true? Could I put different numbers over here and still have those angles supplementary? Yeah, so I could put like 100 here and 80 there, and those would still be supplementary. Because why? What kind of angles are these with the lines and the transversal? They're consecutive interiors, right? Which lines would that make parallel? Yeah, the top are parallel, and that's it. Because it's this, it's kind of like the supplementary ones they're giving you. You could consider this to be a transversal, and then you've got supplementary consecutive interior angles, or you could jump over to the other side and consider that to be a transversal, and it's going to be the same pair of sides that are parallel. Okay, so what could this be if those are parallel and the other ones aren't? You know, because 60 and 80 are not supplementary, right? So the other ones are not parallel. So it could be a what? What is the quad that only has one pair of parallel sides? It doesn't necessarily have to be isosceles, but it does have to be what? A trapezoid. So because you're only going to have one pair, I mean, maybe A and C are congruent and B and D are congruent, but it doesn't have to be that way, right? However, the ones on the left side are split up, the 180 doesn't have to be split up the same way on the other side. So that's kind of the situation that we've got here with, we don't have one angle that's forced to be supplementary to both angle A and angle C. Okay, it would make BC, those supplementaries make segment BC parallel to AD, but could be a trapezoid. Now, they're going to draw these to make you like think, oh yeah, that should be a parallelogram, but it doesn't have to be, you know, like don't assume it necessarily looks like that. So it might be a trapezoid. So here's a trapezoid, which is again not a parallelogram because it doesn't have two pairs of parallel sides. And I could have these being supplementary like 60 and 120, and these being supplementary like 180. And then it really looks the way it's supposed to be looking, right? I probably should have put the 60 and 80 on the opposite sides. But maybe it's a parallelogram, but we don't know for sure. Okay, we don't know if those other angles have to be supplementary. So if you can come up with a counterexample, then you know it's not a true statement. Okay, so this is like your counterexample. Trapezoid, exactly one pair parallel sides. Okay, and then the last one, D, says that segment AB is parallel to CD and segment BC is congruent to segment AD. Okay, so does that correspond to any of these methods up here? I'm going to talk to somebody who hasn't talked to me today. Does that correspond to any of those? Both pairs of opposite sides are parallel. Both pairs of opposite sides are congruent. An angle supplementary to both consecutives, or both pairs of opposite angles congruent. Diagonals bisect each other, or one pair of opposite sides is congruent and parallel. Does what we have there correspond to any of those methods? The second one? Prove that both pairs of opposite sides are congruent. Okay, I'm not telling you that A, B, and C, D are congruent. I'm telling you that they're parallel. So if they were congruent, I would have had to have been able to do this. Okay, but we're given parallel. Grace, do you have a thought? Okay, what does 6 say? I'm not going to zoom up because. Oh, well, maybe they're congruent, but we just don't know that. Okay, if all I tell you, like this is all that I'm going to let you know. All that I'm going to let you know is that BC or B and C are, sorry, BC is congruent to AD, and then AB and CD are parallel. Is it possible for it to be something different than a parallelogram? Because if it is, then, you know, it's not sufficient information. Is there another quadrilateral that has that information, has those properties? There's something else that has a pair of parallel and a different pair of congruent. Let's go back up here. We talked about isosceles trapezoids. We talked about trapezoids in general. We talked about kites. Okay. Are there any of those shapes that has a pair of parallel and a different pair of congruent? Okay. Is it a generic trapezoid or an isosceles trapezoid? So if I draw it so that I have parallel sides here, okay, if these are the parallel sides and the other ones have to be congruent, I've got to make these two congruent. What kind of trapezoid is that going to be then? That'll be isosceles. So this is not sufficient information because remember, we said you had to have the same pair of sides, one pair congruent and parallel. Okay, yes. I'm sorry, I can't hear you. Yeah, so a regular, and I don't say regular because you know how regular means like equilateral, equiangular in math. So we'll just say like a generic trapezoid. A trapezoid that's not isosceles has a pair of parallel sides, but those are called legs. The ones that are not parallel are not congruent. So you might have like a distance of length of 4 over there and a length of like 9 over here. Okay, so this is just a generic trapezoid. A trapezoid in general is a quadrilateral that has exactly one pair of parallel sides. You don't have to know anything else about the other sides. If it's isosceles, then it's going to have congruent non-parallel sides. Okay, so this one is a no because we can come up with a counterexample. It could be an isosceles trapezoid because you need the same pair of sides parallel and congruent. Parallel and congruent to be a parallelogram. Okay, now again, this is like, yeah, this is like a test, right? If I tell you this information, does that necessarily mean, does that force that shape to be a parallelogram? Well, no, like maybe it's a parallelogram and I just didn't give you all the information, but maybe it's not. Maybe it's an isosceles trapezoid instead. Okay, so again, this is your counterexample. If you can come up with a counterexample, then it's a false statement. And that's again an isosceles trapezoid. What do you need to see, Blair? Okay, let me pause for a minute. So notice that again, the first two were yes, because they correspond exactly with one of those reasons from the list. The second two were no, because it's possible to have a different shape that would have those characteristics. Okay. So this one was in, the blue one here was no. And you know, there's like your reason, right? But I'm going to go ahead and I'll write that over here as well. So no could be a trapezoid. A lot of times with these counterexamples, they're going to be trapezoids or kites. Okay, we haven't talked much about kites, so they're not used a lot, but trapezoids will provide nice counterexamples a lot of times. Okay, questions on any of those four?